So our final chapter for this exam is the chapter 10, that is the hydrosphere. So what is hydrosphere? Hydro means water. So the sphere or the portion of earth that is covered with water is hydrosphere. And in this chapter we will be learning about this hydrosphere. So as we know, the Earth's surface is almost 70% covered by water. So it is very important and significant to learn about this sphere, this portion of Earth. So exploring this portion is the primary intention of this chapter, right? So it is a formal definition. The hydrosphere consists of all water bodies on Earth covering about 71% of Earth's surface. The remaining 29% is covered by land masses or continents that we have already learned. The oceans are largest water bodies containing 97% of total water available on our planet. So the major proportion of water that is available on the planet is the oceanic water, right? That is the saline water. Because of massive extent of water, the earth often referred to as blue planet. You have a look at the picture, you can guess that why do we call it a blue planet, right? So this is an introduction to the hydrosphere. Since the 97%, the major proportion of this hydrosphere is ocean. So we will be learning, starting the chapter with the movements of ocean. Movements of ocean means ocean has two kinds of movements. One is called horizontal movement and one is called vertical movement. What is horizontal movement? The movement is called ocean currents. That means the ocean that is moving horizontally along its surface from the coastline of one continent to another continent. Maybe it's from southern to northern part, maybe it's western to eastern part, north to south, whatever. The movement of water is called horizontal movement. We will be learning about the oceanic currents in this chapter and we'll understand what is horizontal movement. Now, what is vertical movement? Do you know about the vertical movement of sea? Have you ever been to any coastline of any ocean? Have we ever seen any waves to get broken in the coasts, in the seashores? So, and other things also there. If you there if you consider the some coasts where the uh, water comes up to the hotels, the ground floors of hotels, covering the entire beach line in the high tide time and during the low tide, they are far away. We have to travel the entire long beach to reach the water. So we have visited those tourist spots where we have seen these phenomena. This is not because of horizontal movement. This is actually the vertical movement of water, ocean, right? Because the height of water increases, the height of the water increases. So it comes along it inserts along the coast to the nearest cities or nearest whatever constructions or whatever hotel or whatever you say. So this is the vertical movement, and in every 24 hours there are two high tides and two low tides, and in every month there are some rotations also. We will be learning about that too. So this is the basic difference between horizontal movements and vertical movements. Horizontal movements are ocean currents and vertical movements are mostly referred to the tides, right? So what are the tides and what is the mechanic? What is the mechanism? What can be the mechanism that causes this rhythmic rise and fall of ocean water? Have you ever think about that? That you have visited some coastal region and you found that in the evening or late night the water is coming to the doorsteps of your homestay or hotel, whatever you have stayed, and during the daytime you have to travel along in the beach to reach to the water, to touch the water. Have you ever have you ever wondered about it, that what is the reason behind it? So we will be learning about what is the reason behind it. So this is the mechanism that is called tide. Tides are actually the result of gravitational pull of moon and sun. To some extent it is sun, and mostly the position of moon that causes the high tides and low tides. Tides are alternate rise and fall of ocean surface twice in about 24 hours. They are caused primarily by gravitational pull of moons and to a lesser extent the sun. Though the sun is larger, the moon is much closer to earth, right? Exerting a strong pull on earth's water. Tides strike the coast in the interval of exactly 12 hours and 26 minutes. So in every 12 hours 26 minutes interval we have a tide. If we call it high tide, then we will find the water is coming, means upwelling, and low tides are also tides. So in during the low tides the water becomes far away from the coastline or from the city, right? So you can see the image, you'll understand it. So this is the first case, the new moon spring tide. That is when sun, moon, and this is earth. Sun, moon, and earth in a same position, and moon is between sun and earth. Then this gravitational pull is very high, and spring tide is taking place. Again, when the sun, you see, if you if you see the picture image very carefully, you'll find that once the gravitational pull of moon causing the upwelling of water over here, also the same upwelling is taking place just at the opposite of the earth's means whatever uh, spheroid, earth's spheroid. So here is a high tide, here is a low tide, here is a high tide and here is a high tide, and this along this north and south part there's means in this situation particular time they are they are experiencing low tides, right? And this is for new moon means just during amavasya we say, right. And during full moon means that is Purnima, the position of moon is just opposite the sun, and the same thing happens. The moon is pulling the water here, and the opposite in opposite direction also water gets upward, and these are two opposite these two north and south means these two right angle parts are having low tides, right? So this is happening during spring and full moon tide, right? These are called these are called uh, spring tide and spring. Both of them are called spring tide. Pardon. And now coming to another situation. In both the cases, the earth, moon, and sun are in a same line, right? But the moon is rotating around the earth. So for every 24 hours it is having a position here once in 24 hours, once in 24 hours. That's why we are having high tides twice a day around an interval of 12 minutes 26 seconds, and sorry, 12 hours 26 minutes, pardon. And now what happens when moon is here or here means the position of moon is nearer to north or south pole, then these tides are called neap tides. Neap, N-E-A-P, neap. First quarter neap tide. First quarter means if we start this uh, circle, so we can divide it in 4 quarters. First quarter means 1/4 of the moon's travel path is 1/4 of the entire cycle, right? So this is the first quarter moon, and this is pulling this water towards it, means the high tide is in north and south pole, and these two east and west are facing low tide, right? But these gravitational pulls are lesser than these spring tides. Why this is so? Because here the sun in a lesser extent, but sun, what does it do? It nullifies, it cancels out the gravitational pull of moon, right? So the intensity of high tide is a bit, comparatively bit lesser in case of when the moon is here, or when the moon is at the third quarter, right? This is first quarter, this is half, this is third quarter, right? So these two tides are, that's why these two tides are called neap tide. These all are happening in 24 hours, but the position of sun, means the full moon and the first moon, these are happening once in a month, right? Once in a month, the position of sun, moon, and um, earth in a same line is happening once in a month for full moon, once in a month for first moon, right? And so, and for moons, this lunar rotations around the earth, every high tide and low tide is taking place in every almost 12 hours. So in 24 hours we get 2 high tides and 2 low tides in any area, right? So this is what I just explained in the last image. The spring tides that occur when the earth, moon and sun align in a straight line. Gravitational forces combine, producing the highest tidal energy, very high tide, very low tide, and occur twice in a month, full moon and new moon. And neap tides are when the moon and sun are at right angles. You just recollect the image, and gravitational forces oppose each other, producing the lowest tidal range, and occur during the first and third quarters of the moon. Now, what is the function of this of these tides? So, these tides have some impacts on our economy, our lifestyle, and many more things, like navigation. For navigation, the country's navigation, ships and commercial ships, they sometimes they depend upon the tide waters, like Thames, Hooghly River also. The harbors, the ship can enter into the harbors only during the high tides. Cleans harbors, the harbor can be clean during the high tides, and wash off the all the means, uh, you know all the um, chemicals or any spillover or anything, any byproduct of this coastal, means this harbor transaction of products and anything. So these are getting washed off during the high tides. It prevents freezing in the cold countries, cold regions. The water is very prone to get freezed. Because of this high tide, low tide movement, the water is can't freeze properly. So this is good for economy also. And salt production during high tide, in the coastal region, in the harbors, this high tide water deposits salts, and during low tide human can collect it for any commercial purpose. And tidal energy is very important alternative source of energy. Using this movement of means this vertical movement of water, we can produce some energy that is always a non-conventional and renewable energy, right? Now coming to the horizontal movements. So vertical movements and tides we are means aware of right now, and now we are moving to the horizontal movements. So there are several factors that influence these currents, like the position of moon and sun, that influence the tidal currents. And here in horizontal movement, the factors that influence the horizontal currents are winds, temperature, salinity, and Coriolis effect. Winds are very important and impactful factor. Steady winds physically push the surface water onwards and initiating horizontal movement of vast ocean current. Temperature and salinity is also where temperature is very important, and salinity. Temperature, salinity are very crucial for this movement, because variation is in heat and salt, salt content, that means the density that makes the water uh, move from the higher density to the lower density. That is the natural feature of water. So this vertical convection currents are formed, and that's why the water horizontally move from one place to another. And Coriolis effect is very important thing. Coriolis effect is a force. This is basically an effect that is caused by a force that is due to the Earth's mm, Earth's rotational movement. For Earth's rotational movement, the water and air that deflects clockwise in the northern hemisphere and counterclockwise in the southern hemisphere, and these forces are called Coriolis force, and this effect is called Coriolis effect. So neither the air, nor wind, nor the water can can flow vertically on the surface of Earth. It always gets deflected either right or towards left because of this Coriolis effect. And this law is called the Ferrel's law. Ferrel's law. Who invented this Coriolis effect? According to his name, this law is called Ferrel's law. Before we enter into the directly to the exact streams and exact flow of streams, let's divide these global currents into three major currents. One is Atlantic Ocean current, the warm Gulf Stream. We will be learning about Gulf Streams and all, Labrador currents and these things. We will be reading about it. Then Pacific, the Kuroshio current is the major, and then Oeshio current. They have immense impact on fisheries, right? In coast of Japan, the huge economy is depending upon these currents. And then Indian Ocean, here the current undergo complete reversal, that is monsoon drifts between summer and winter due to shifting regional seasonal winds, right? So these are the three major groups of oceanic currents. So let's have a look upon the oceanic current. Well, these are the major global oceanic ocean currents and their directions. The red arrows are warm currents and the blue arrows are cold currents, right? So this is Pacific. Let's start with Pacific. In Pacific, this is North Pacific drift. This is Kuroshio current. These are hot water warm currents, but this is Oeshio current, which is a cold current. This causes the cooler coastal region, and this supports fishing. Now coming to California current, this is also cold current, right? Then we are coming down up to equator, so this is equatorial current, warm current, and East Australian current, that is means along the east coast of Australia, that is also a warm current. But West Australian current is a cold current, right? And now coming to this part, Atlantic part. This is Pacific, this is Atlantic. Now we will be coming to Indian Ocean finally. So first let's have a look at the Atlantic current. North Atlantic drift, Gulf Stream, all are warm currents basically. And this equatorial current, Brazil current, these are warm currents basically. And there are some cold currents like Labrador. This is coming from northern, means not near North Pole. This is coming from cold region, and this is called cold Labrador current. Just like Oceanic current, Labrador current has huge impact on coastal economy, right? Then Canary current, this is also cold current. Venezuela current, Falkland current is also a cold current, and Peru Humboldt current. This is also a cold current. You just try to see the equatorial line. Equatorial line. You have to understand that mostly the currents coming from north and south pole or flowing from north and south pole are mostly cold, whereas which are flowing in near the equator and all, these are warm currents. Right, now coming to Indian Ocean, there is a huge change due to monsoon has a huge impact upon these currents. So there are some currents like equatorial current. This is equatorial current, some Agulhas current and all. And now coming to, this is near the southern Antarctica, southern pole. So Antarctic polar current is cold wave, Falkland current, and these currents are cold wave, right? Peru current is also cold wave current. So you have to remember a few major currents like North Pacific, Kuroshio, California, Oasis, Labrador, North Atlantic, Gulf, Canary, right? You have to remember these currents. Australian currents you can remember, Peru current you have to remember. These are the few currents you have to remember, right? This is very good, very interesting thing that uh, what we understand, or before I learned about this oceanic current, I used to think that oceans stay as it is, but actually the global ocean network is working as a moving object, moving water body, global water network, oceanic network. Internal rivers and water bodies also, the flowing rivers, not the static ones, means the lakes and all, but the flowing rivers, they are also mixing to these oceans. And so the entire water on the earth is moving, exchanging their places, and it is a very big body of continuous movement, right? So this is the big picture of all the ocean connectivities and currents. If you don't understand anything, or if you have any query, write it down and let me know, right? So what are the impacts of these currents? So we learned about the impacts of tides. Tides has immense impact in our economy, energy generation and all. So what are the impacts of these currents in our life, in human life and other lives, other means biodiversity? So climate and weather, warm ocean currents raise the temperature of coastal areas and bring moisture for rainfall. Conversely, cold current chill the onshore winds, keeping adjacent deserts colder and drier. And economy and navigation, it has a huge impact on weather, climate, controlling weather, climate, and controlling economy. Economy, mixing zone of warm and cold current creates ideal condition for planktons. That is very productive part of the water body, where the cold current and warm current mixes, that becomes a very productive part, where the several planktons and several plants and animals, aquatic plants and animals grow and survive. And currents also assist the ships in sailing faster than when traveling in the direction of the flow. If you travel in the direction of the flow, then the ships will be uh, ships will be actually accelerated with the help of this current, right? Now here are some practice questions, but obviously these are just examples. You have to go through the entire exercise of your copy of your book, and after that you have to practice more from. I'll provide a few more questions from anywhere. I'll collect it and send you, and you have to practice them also. So these are just few examples of questions. MCQ, the answers are given, and also some short answer questions, and the answers are given. Tide formation, Coriolis effect, current effects, and all. So these are just examples. These are not final things, right? You have to study more. You have to practice more question answers to prepare this chapter. But this is very interesting chapter. I believe you liked it, and if you have any query, please ask me.